A very good day to all of you. My name is Dorestey Sindam. My matrix number is B051810201. Today, I would like to present my bachelor degree project 2. The title is FTIR and Porosity Analysis of the Moisture Exposed 3D Printed PLA and TPU Filaments. Introduction. Additive manufacturing (AM) is the industrial production name of 3D printing, a computer controller process that creates three-dimensional objects by depositing materials and usually in layers. According to Subramaniam and others, 2019, one of the most common additive manufacturing technology is fused deposition modeling (FDM). Other than that, thermoplastic filaments like PLA, ABS, PETG, and TPU is hygroscopic and tend to absorb moisture when exposed to a humid environment, which can affect the quality of the print parts. Problem statements. The main consequences of moisture in the filament are degradation of the filament. The hygroscopic filaments are prone to absorb water greatly since the water molecules are attached to the polymer molecules, forming strong and intermolecular bonds. Based on research Pagnin and the others 2021, the way a filament exposed to the moisture can affect the state of polymeric chemical chain situation. According to Li Peng and the others 2020, being affected by environmental temperature and humidity will make the 3D printing uneven surface, causing the 3D printed result to be porous. Scope of study. A red color of PLA and TPU filaments with a diameter of 1.75 mm manufactured by Sunlu are used for this study. A maximum of condition exposed with the humidifier in this study was 150 hours and the minimum was 48 hours for both PLA and TPU filaments. Porosity analysis was conducted using a densimeter due to the lack of porosity equipment at the laboratory. The Archimedes principle is explored in this method, where less density indicates a highest porosity levels. A spatter coating powder coat material used for this study are 20% palladium and 80% gold. Literature review. Author Bhagia said the thermoplastic filament of 3D printing left in moisture will be absorbed in the plastic. It will be affected by humidity, which causes the final 3D printing. Bob Beckery said the change in chemical properties of thermoplastic polyurethane (TPU) system in different temperature and atmospheric moisture. Leon said Fourier transform infrared (FTIR) spectroscopy analysis was used to identify change in the chemical structure of the transform on filaments. FTIR result will show the intensity of the peak transmittance. Slotwinski said Archimedes method was used to measure the density and porosity of the fabricated part. Furthermore, it's very useful to calculating the fluid displaced volume equal to the object volume. Guo said SEM is widely used technique to characterize solid material, morphology, topology, and detailed surface structure. The process of plastic 3D printing will appear in several times magnifying using a SEM machine. Methodology. The methodology of this study shown in Figure 3, which is flowchart of study. The first step is preparing PLA and TPU filaments under undry condition. Then design the CAD model and generate the STL file, and then convert to Cura software by generating slicing file. In addition, the material preparation, which is PLA and TPU filaments, will be exposed for 4 conditions, and each condition will come out with 3 samples. The next step is continue with 3D printing of the filament to test the FTIR analysis, density test, and microstructure analysis by SEM image. Preparation of PLA and TPU. 4 conditions. First, new filament roll, which is as a reference. Second, use filament roll stored in vacuum bag with 50-gram silica gels. Third, use filament roll stored in vacuum bag without a silica gels. And lastly, use filament roll stored in open environment exposed for 48, 96, and 150 hours to a humidifier. Figure 4 shows the 3D CAD model by dimension 10 mm cube by using AutoCAD 2022 software. 3D printer, the brand that we use is Ender 3B2. Parameter setting for 3D printing is same for PLA and TPU. Printing temperature is 220 degrees Celsius. Bed temperature is 60 degrees Celsius. Printing speed 60 millimeter per second. Filling percentage is 10%. Layer thickness is 0.1 mm. I choose this shape because it's suitable to be analyzed using FTIR machine and insert into SEM machine to analyze. Figure at FTIR machine. The brand is Jasco FT/IR 6100 to analyze the influence of water in the polymeric chemical. Figure 9 is densimeter, is an analytical balance scale to measurement method with distilled water in use to measure the exact mass of sample in water and air. Figure 10 is Archimedes' principal formula to figuring out how porous a substance was used to figure out how dense material was. Figure 11 is a mini sputter coater. The brand is SC7620 to utilize in this study for sample analysis so that the same image could be desired quality. And figure 12 is same machine. The brand is Carl Zeiss Evo 50. Same analysis is figure out the influence of humidity on the structure, result and discussion. FTIR analysis for PLA specimens. Chemical change group OH is hydroxide ion. CH is carbon-hydrogen bond. CO is carbon monoxide. The peak or stretching bands transmittance that will be analyzed on this graph according to the box of OH. Still at PLA specimen analysis. According to Olam and Tosun 2022, the wave number range of the presence of water or hydrogen is around 2800 cm1 until 3000 cm1. Figure 14 shows the maximum OH bond is when exposed to the humidifier for 150 hours, followed by 96 hours and 48 hours. Next, as we can see, the condition of PLA that was stored in vacuum bags without and with silica gel can be seen to have a more or less peak level. The minimum OH bond is condition of new PLA filament is as a reference. FTIR analysis use TPU specimen. Figure 15 show the bonding of OH, CH, and CO, a spot in the specimens. That is, the presence of OH was identified. Still at TPU specimens analysis. Figure 16 demonstrates the presence of the OH bond in TPU printed filament in a range of 2800 cm1 until 3000 cm1. The maximum transmittance of OH chemical bonding was spotted in TPU specimen exposed to a humidifier for 150 hours, while the lowest peak of the OH bond belonged to the reference specimen. Based on research Pagnin and the others, 2021, how a filament is exposed to moisture can affect the state of the polymeric chemical chain situation. So we can conclude that the highest humidity is the highest of peak transmittance because of filament that was influence of the moisture or humidity, influence of the water in the polymeric chemical change bonding in the 3D printed filaments. Other than that, PLA and TPU have a similar characteristic. Both filaments are hydrophobic and easily absorb moisture for 3D printing. On a micro scale, a shorter polymer chain means a filament becomes more brittle than flexible and it is called hydrolysis. Hydrolysis can cause filament to break before it's fed into a 3D printer. Unfortunately, hydrolysis can be reversed by drying the filaments by Zyrolizum and others 2021. Density analysis using PLA specimen. Table 2 and Figure 17 show the data collection and the bar graph of PLA 3D filament densities measured by the densimeter under different conditions. Neofilament rolls have a maximum density, followed by the used filament rolls preserved in silica gel and then without silica gel. The bar graph reveals decreasing, followed by the 48 hours and 96 hours filaments. The 150 hours filament has a lowest density. So the large density filament has a lowest porosity. Porosity affects printing Therefore, keeping material in good condition is important. Lowest density causes the most porosity and the prints had porous filaments. Wet filaments reduce strength and layer head hasten, creating an abnormally fuzzy print surface. Density analysis by using TPU specimen. Table 3 and Figure 18 illustrate data collection and bar graph 3D printed TPU filament density. New filament rolls have the highest density, followed by the used filament rolls in silica gel and without silica. Then 48, 96, the second lowest density. And the most lowest density is the filament that was exposed 150 hours humidified. In general, TPU filament stored in a great condition has a highest density. The highest density filament has the less porosity, and the lowest density has the most. Other than that, the difference between PLA and TPU is not as large as in other filaments. Despite material variation in both, density was affected by filament condition. Microstructure analysis using PLA specimen. As the outcome of the same, Figure 19 show the structural difference with 30 times electron magnification power. There were three surface morphology gap length positions taken in each of the specimens and averaged the length value. Structural changes are visible on each same image, although the significant change in length. Table 4 shows the length of the structure in same image of PLA part. The longest of PLA filaments exposed to humidity for 150 hours, followed by 48 and 96 hours of humidification. Next, the shortest surface gap length is the new filaments raw PLA, followed by filaments raw PLA stored in vacuum bag with silica gel and without silica gel. According to Kalenke and others 2022, the effect of humidity can change the structural change of the 3D printed specimens. Microstructure analysis using TPU specimen. Figures 20 below show the image of TPU specimens in same image with 30 times electron magnification power. Table 5 shows the surface gap length of TPU parts. The longer its condition exposed is 150 hours. The shortest is a new filament roll TPU, followed by filament roll TPU stored in a vacuum bag with silica gel and then without silica gel. Humidity on the filament expanded the surface morphology gap, affecting printing. The longer the surface morphological gaps, the more significant the structural change of the humidity on 3D printed PLA and TPU filaments. Based on this study, the highest density is material PLA compared to TPU. TPU is more porous and void under the same image than PLA structural. In conclusion, Objective 1. Achieve the analysis of the influence of water by using FTIR machine. The highest peak transmittance of the polymeric chemical chain is the highest of moisture exposed. Objective 2. Successful measuring the porosity using Archimedes principle. The porosity increased due to the lower density. Objective 3. Accomplished observing the structural change using same image. The large surface morphology gave the highest of porous in the filament of 3D printing. Thank you. That's all from me.